Hi everyone, continuation of Unit 2. Now I'm going to discuss about ADPCM and ADM principles. Okay, so and first we'll see about ADM, which is adaptive delta modulation. Okay, okay. So what is adaptive? So adaptive means it has to adapt itself automatically. So what we require, that should be attained by the system itself. So by the making of iteration or by looping method, so whatever it is, so the signal, whatever the data we require, that should be obtained by using adaptive methods. Okay, so that is called adaptive. So what we faced, the drawbacks in delta modulation, that is quantization error in slope overload and granular noise. Okay, so what will happen, the step size is made adaptive to variations in the input signals. If it is the step size is increased, it's somewhat increased, automatically your high logic will be updated, and step size is reduced gradually, your 0 will be added. Whereas in delta modulation, is there is any single changes in the up down staircase, your data could be changed. Whereas here there will be some adaptive concept included here. So the thing is, the particularly in the steep segment, so when it is going towards to the up to steep segment of the signal, the step size is increased. So when the input is varying slowly, okay, so when the input is varying slowly, the step size is reduced. Okay, when it's going for steep segment, step size is increased, and it's varying, its step size is reduced. So this will happen depends on the signal, okay, not by the user. So how the signal it's represented is based on that, your step size could be calculated. So what we have seen in positive delta and negative delta, that could be adjusted based on the signal, that is called adaptive. Okay, so the adaptive delta modulators can take continuous changes in step size or discrete changes in step size. It can take continuous change as well as discrete change, that is both are possible. So the same thing what you have seen in digital modulator, the only one logic has to be included, logic for step size control. That is the only change we made from the delta modulator. So the what it will do, the logic for step size control, whether it's increasing steep segment, step size will be increased. It's varying slowly, then your step size will be reduced. That control which is available in the logic for step size control. Remaining all are same what you have discussed in the digital modulation. The same thing here also for receiver, logic for step size control included before the receiver section of digital modulator. Okay, and this is the waveform for the adaptive delta modulator. See, here the staircase couldn't change often. So when it is going steep, your del 1 is increased. Okay, when it is getting down gradually, slowly, okay, your value becomes 0 0 0. Okay, so when 1 1 1 1 and 0 0, you just compare with delta modulation waveform and adaptive delta modulation waveform, you could easily understand the difference. So what is the advantage of ADM? That is, the signal to noise ratio is better than the ordinary delta modulation. Okay, and also it's a reduction in the slope overload and granular noise because of the variable step size and dynamic range of ADM. Okay, and utilization of bandwidth is better than delta modulation. Bandwidth also here we can utilize better than the delta modulation. Similar to delta modulation, only 1 bit per sample is required, and simplicity of implementation of transmitter and receiver as like delta modulation. That is adaptive delta modulation. Very simple when if you study with comparison. Okay, so the delta modulation, which is used to reduce the bit rate, right? Here only one bit only are going to transmit. So further we are decreasing the signal rate by using adaptive delta modulation by varying the step size. Okay, so based on the signal, step size should be adapted. So that is the thing in adaptive delta modulation. Okay, then next one is ADPCM, so adaptive differential pulse code modulation. Adaptive differential pulse code, already we seen differential pulse code modulation, right? So differential pulse code, we have different levels based on the our input waveform. So levels are assigned. So we reduce the redundant bits, right? Redundant samples has to be reduced by using differential pulse code modulation. The same thing here we are using adaptive. Okay, so based on the signal that redundant values reduced, and it automatically it is getting assigned. That is the meaning called adaptive. So adjusting to changing level and spectrum of the input speech signal. Okay, that is the main thing here. Okay, and why we are taking is a speech signal. Speech signal, it varies. If I am talking slowly, my sound wave should be an lower amplitude. I am talking in high pitch, my amplitude gets varied. So based on the high pitch and low pitch value, waveforms will get varied. Okay, so that in that case we need to adapt the codes. Okay, so that's what we are taking the speech signal. So digital coding scheme that use both adaptive quantization and adaptive prediction. Okay, so here we used two technique, adaptive quantization as well as adaptive prediction used in the ADPCM technique. If it is ADPCM, adaptive quantization can be performed using adaptive quantization with the forward estimation and with the backward estimation, and prediction the same way, performed using adaptive prediction with the forward estimation, prediction with the backward estimation. So you must clearly state the difference. Adaptive pulse code modulation, differential pulse code modulation can be configured and be designed using adaptive quantization and adaptive prediction. Based on that adaptive quantization and prediction, we have a two classification: forward estimation and backward estimation. So that is the difference. You must clearly understand that. What it will do, forward estimation means there is no feedback. A simple thing, there is no feedback. So whatever the signal which it's coming through the input, and it's be buffered and given to the level estimator, and that level estimator will give the particular values. Okay, so for like 7 levels, we have taken 11000 to 111, so it takes 7 levels. So like that, it give the level that is encoded by the encoder and transmitted to the channel, and a decoder will receive and again reconstruct the original data. So there is no feedback in this forward estimation. It is adaptive quantization with forward estimation. And whereas in with backward estimation, so we are having a loop, right? So encoder is there, and the encoder data again it's given to the level estimator, again forwarded to encoder, then it is given to the channel. That channel data which goes to level estimator as well as goes to decoder, and it should be compared and giving the output. Okay, simply just keep remember, backward estimation you will be having a loop, forward estimation you don't have any loop, right? In this both the cases we are having encoder and decoder. Okay, and the same thing, adaptive prediction, okay, with the forward estimation. Already we studied out prediction filter, okay, quantizer and predictor. Here we have used the same prediction filter. In before that, buffer and predictor coefficient calculator, all those things which is before the prediction filter, and we estimated and given to the prediction block and transmitted over the channel. Okay. Whereas in backward estimation, the same thing, it should be getting looped. Okay. Then logic for adaptive prediction and given to the predictor, again it's getting the difference and quantizer value. So everything what process we have seen in a prediction filter, that is to be looped. Okay, that is adaptive prediction with backward estimation. So this is ADPCM logic. Okay, so I hope you understand both ADPCM as well as ADM. Okay. Thank you.